Hello everyone. In this video, I'll be talking about the Intermediate Value Theorem. The Intermediate Value Theorem states that if f is a continuous function on some closed interval ab, and there is an n that exists between f evaluated at a and b, the two endpoints of the interval, and f of a does not equal f of b, then we must have that there is a c in the open interval ab such that f of c is equal to that n. Let's show what this means with a graph. So here I can just draw some continuous function f. Doesn't necessarily have to be increasing like this, but we have points a and b which have a corresponding f of a and f of b. Then we can choose an n that resides between those two evaluated endpoints, and IVT says that there is a c that corresponds to that n. The big thing to remember about this is that we can only make these conclusions because f is continuous. Suppose f was not continuous, like it had a break in our interval and we had to choose an n that landed in that break. We can't make the same conclusion about there being a c for that n. Now, where is IVT used? Typically we use it to find if a particular equation has a solution on a given interval, and we will go through some examples of such questions about that. Before that, however, let's go over the framework for answering IVT questions. You're usually given an equation f of x on some interval ab, and this function is continuous on this interval, which allows you to use IVT. Note that you don't have to be given a closed interval necessarily, it can be open as well. The function just needs to be continuous on the closed interval ab, which usually happens when the function given is continuous everywhere. You are then asked to show there is a solution to f on the given interval, i.e. there is a root. What that basically means is a point where f of x is equal to 0. This happens when one of f of a or f of b is positive and the other is negative, depending on whether the function is increasing or decreasing. We let n equal 0 since we are investigating whether there is a root, and see if there is a corresponding c, again if we get a positive and negative value for the two evaluated endpoints f of a and f of b. It's important to note that IVT does not tell us what c is, it just tells us whether there's a c where f of c is equal to n, in this case 0. Let's go over some examples. For negative x to the third plus 4x plus 1 on the open interval negative 1 to 0, first we have to mention that the function is continuous everywhere, thus it is continuous on our interval of interest, the closed negative 1 to 0. Now all we have to do is evaluate the endpoints of that interval. F of 0 gives us 1, and evaluating f of negative 1, if we work it out, will give us negative 2. Thus we have a positive and negative value like we are looking for, and 0 exists between those two values, so we can conclude that this function has a root in the given interval. Now for the second example, we have to rearrange the function to get all the terms on the same side, and then we can have a function we can work with. If we investigate, we see that this function is composed of three continuous functions. Thus we have a function that is again continuous everywhere, and therefore also continuous at our interval of interest. We evaluate the function at the two endpoints, and we see that f of 0 gives us negative 2, and f of 1 gives us e minus 1. E is approximately 2.718, so this is going to give us a positive value. Again, what we found lets us know that there is a root in the interval from 0 to 1. To summarize, the general process of solving these type of questions are as follows. You state the function is continuous, and it's even better if you can show why or how. Then you evaluate f and the two endpoints of the interval given. After that, you explain that since 0 is between the two endpoints evaluated, we have a root. Now you may not always be asked to show that a function has a given root at a certain interval. You could be asked something more general like this. Say we have f of x is equal to x squared plus sine x, and we want to show that there is a c such that f of c is equal to 1000. How would we go about doing this? First of all, we gotta ask, is f of c even in the range of f? Let's take a look by breaking apart our function. Sin x smoothly oscillates between two values, -1 and 1, and x squared ranges from 0 to infinity. The x squared term dominates the sin x term as it grows and approaches infinity, so 1000 is definitely in the range. The other thing we have to ask is f continuous? Well, x squared is continuous and so is sin x, so the answer to that is yes. In fact, f of x is continuous everywhere. Now we can use the fact that f of x is equal to 0 at x equals 0 because x squared and sin x are both 0 at x equals 0. And the function goes to infinity as x approaches infinity to say that 1000 will show in this range. And we can choose some x subscript L so that f subscript L gives us something like 1001, which is also in our range. And then our n, which is equal to 1000, is between 0 and 1001, and therefore between 0 and x subscript L, we have some c such that f of c is equal to 1000. And there we've shown what we wanted to show. We could have also chose some other arbitrary x coordinate that gives us 999, which also exists within the range, and use that to show the same thing. The steps would have been similar in that version. I hope this explanation and these examples helped you understand the intermediate value theorem, and thanks for watching.